Our picture now is a little bit cluttered, so let me just make sure we understand where we are. We've constructed a power 2.5 graph here in white. Now I'm going to trace that graph a little more clearly, but the points on the graph are here, here, and here, and I've sketched this white curve. I'm going to sketch once more. Through those 3 points. Now, this point projects over to here where the y-coordinate is 0.2. This point projects over to y-coordinate that I estimated to be 1.7, and this to a y-coordinate that I estimated to be 10.5. So that's where these numbers 2.2, 1.7, and 10.5 come from. And they're in white, and I used a white color to label the graph, to identify it, and to construct it. Then I constructed the orange graph. Okay, I have a point here, a point, where in the world is the point? Okay, here, and a point here. I sketched my orange curve, and I'll repeat that. And of course, the graph was constructed before I put a scale on anything. I didn't use any numbers excuse me, to construct the graph. But having put the scale on it, now I've got 1.2 for the y-coordinate of this point, 3.5 for the y-coordinate of this point, and 8.7 for the y-coordinate of this point. Now, somebody's talking a little bit loudly out in the hall. I need to close the door. No fault to anybody there. It's one of our buildings and grounds crew and talking to somebody a little further down the hall. So I should have pulled the door in the first place. Okay. Now, so we have the y-coordinates of these 3 points. We also estimate the x-coordinates of the 3 points. Okay, and I used the same x-coordinates, which turn out on this graph to be 2, 4, and 8 once I put the scale on it, or very close to those values. So we get the x-coordinates, okay? Now, what we've done then is constructed a tangent line to this graph that's parallel to this blue chord, which goes from this point located on the graph to this point. Now the slope of that tangent line should be equal to the slope of the blue chord. I estimated the slope of the green tangent line here, and also the coordinate at which it meets the graph. We appear to have at x-coordinate approximately 6, we appear to have a tangent line parallel to the blue chord that goes from x equals 4 to x equals 8. We construct a triangle, right triangle, and estimated this side of the triangle to be 1.8, this side to be 3.3, giving us a slope of 1.8. It's actually between 1.8 and 1.9. Now it's going to turn out that the slope of the blue chord, which is supposed to be the same as the slope of the green tangent line, was 2.2, which is close to, but a little bit different than the 1.8. Now the difference could be partially explained by the fact that I did an estimate here, and I could have estimated this distance to be 1.7 or 1.9 perhaps. This distance, which I estimated to be 3.3, could have been somewhat different. So there's some uncertainty in all these estimates. There's some uncertainty in the graph due to the fact that it's hand sketched. In any case, we can take the numbers that we now have and calculate the slopes, in this case, of all the blue line segments, which should be equal to the slopes of the tangent lines. That is, this tangent line should have the same slope as this blue segment. This tangent line should have the same slope as this blue segment. And this tangent line here, which it's in blue, actually there's a tangent line in green. I didn't try to draw it. There's too much stuff on the board there. But we have a tangent line here. And then we have the purple tangent lines here that have the same slopes, or should have the same slopes as this, and this blue line. Now, instead of calculating the slopes of the tangent lines, I'm just going to use the coordinates we've estimated for the points on the graph, which will give us the slopes of the blue lines that the tangent lines are supposed to be parallel to. Those slopes should be the same. So for the f of x function, our power 2.5 function, we get a slope of 0.2 minus 0. That's the 0.2 y-coordinate of this point minus 0 y-coordinate of this point minus 2 minus 0 in the denominator. That's rise divided by run, and we get 0.1. And we estimate that that tangent line occurs at this point here, which is where x equals, I estimate, 0.8. Then we calculate the slope between this point and this point. Coordinates are 1.7 and 0.2, y-coordinates. X-coordinates are 4 and 2, so that the slope is calculated here, 0.75, and we estimate that tangent line occurs at x equals 3. Then we estimate slope of this segment, which should be parallel to the slope of or the same as the slope of this tangent line. Using the same idea, it should be clear where the numbers come from, and now we get a slope of about 2.2, which, as indicated earlier, doesn't agree greatly, really well with the 1.8. It's off by maybe 15%, but it's still in the right ballpark. Then for the g of x graph, we make similar estimates. The first segment of this graph, or the first blue line here, it has y-coordinates that go from 0 to 1.2, so the rise is 1.2 minus 0. X-coordinates from 0 to 2, so the run is 2 minus 0. We end up with a slope of 0.6, and we estimate that that tangent line occurs when x is about 1.2. And then we make estimates for this and this, giving us the slopes of this purple tangent line and this purple tangent line, and we estimate the coordinates at which those purple tangent lines are tangent to the curve. So that's where we get the x equals 3 and 6, and the slopes 1.15 and 1.3.